So suppose that we had the following function. How would we find the inverse? It's important to note that if we have a function such as f of x equals 3 to the x, and we had another function g of x equals log base 3 of x, that these two functions are inverses of each other. We can tell because when we graph them, they're going to be symmetric with respect to the line y equals x. But what happens if we compose two functions that are inverses? Well, what would happen is no matter which way we compose them, whether we put it as 3 log base 3 of x, or if we did log base 3 of 3 to the x, however we combine them, we would just end up with x. In other words, the log base 3 and the base 3 would cancel each other out. So this log base 3 and this 3 would cancel, base 3 would cancel each other out. So that's important to help us out later in rewriting this. So the first step in solving or rewriting this as an inverse function is to write this in a friendlier form. So we're going to say this is y equals 9 to the x plus 3. Let's suppose that we wanted to find the inverse, so now we would switch the x with the y and the y with the x. So they're going to change places. So now what we have would look like x equals 9 to the y plus 3. We want to get y by itself, which means that we need to get this exponential by itself. So to do that, we would need to subtract 3 from both sides of our equation. We would end up with x minus 3 on the left and 9 to the y on the right. So now let's use that fact that we said before. Notice that the base here is 9. So what would happen if we did a log base 9 on both sides? So if we did the left side, so log base 9 of what was already there, which is x minus 3, and then we did the same thing to the right side, so log base 9 of 9 to the y, which was already there. So what would happen? The log base 9 and the base 9 would cancel each other out, which means that we would just have y on the right side. So now we have log base 9 of x minus 3 is our inverse function. And we can write this either as a new function letter, or we can use what we have here, f inverse of x, or the inverse of our function is going to be log base 9 of x minus 3. The range of log functions are always the same. They're always going to go from negative infinity to positive infinity. The domain is whatever makes the argument of this particular log function positive. So what would make this x minus 3 positive? Well, let's find out. So x minus 3 has to be greater than 0. So if we solve for x by adding 3 to both sides, then x has to be greater than 3. So our domain is going to be from 3 to infinity. So to get our y-intercept, our x-intercept, we're going to set our function equal to 0. So if we did log base 9 of x minus 3 and we set that equal to 0, what we could do is we could use the same, not trick, but information that we said at the beginning about the base and the log with the same base, that they're going to cancel each other out. So if we put the left side as having a base of 9 and the right side as having a base of 9, on the left side, the log base 9 and the 9 would cancel each other out. So that leaves us with just x minus 3. Any number to the 0 power is 1, and we can add 3 to both sides. So x here would have to equal 4. So our x-intercept would be at 4, 0. The domain tells us a little bit about the asymptote. Notice that we can't have x being equal to 3. So our domain, our asymptote would be at x equals 3. So if we wanted to find the inverse of this function, we could apply the same steps. Go ahead and pause the video. Try and see if you can do this one yourself. So what we need to do is we would need to, first of all, write this in a friendly format. So y equals 6 to the x subtract 2. We could then switch the x and the y. They're going to change places. So this would become x equals 6 to the y minus 2. We want to get y by itself, so that means that this exponential has to be by itself. So we need to add 2 to both sides of our inequality, our equation. On the right side, it's going to cancel out, and on the left side, we have x plus 2. From what we discussed before, we can raise both sides or apply a log of base 6 to both sides. So we do log base 6 of what's on the left side, which is x plus 2. And we can do a log base 6 on the other side as well, on the right side, to what's already there. So remember, the log base 6 and the base of 6 are going to cancel each other out. Now we're just left with y. On the left side, we have log base 6 of x plus 2. So this is our inverse function. So our inverse function can be rewritten as f inverse of x equals log base 6 of x plus 2. What about the attributes? We know that for the range is always the same for a log function. It's always going to go from negative infinity to positive infinity. For the domain is whatever is going to make the argument, whatever is going to make this part of it positive. So we're asking the question, when is x plus 2 greater than 0, or when is it positive? So we would have to subtract 2 from both sides of our inequality, and so x is greater than negative 2. So our domain, our acceptable x values, would be anything greater than negative 2, and moving forward, so all the way to infinity. To find our intercept, we need to set this function equal to 0. So log base 6 of x plus 2 equals 0. The base is 6, so we're going to make 6 the base on both sides. 6 to the 0 is 1, and the log base 6 and the base 6 are going to cancel each other out, leaving just x plus 2. We subtract 2 from both sides of our equation, and that tells us that x is equal to negative 1. So our x-intercept is going to be negative 1, 0. To find our asymptote, we've already basically done the work. Remember that in our domain that we cannot include negative 2. So our asymptote will be x equals -2.